Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty interesting problem, guys. I'm very excited about it. So yeah, let's read it real quick. So it says, given a binary search tree, right? Find the lowest common ancestor of two given nodes in a BST, right? It says according to LCA, right, the lowest common ancestor, right, is defined between the nodes P and Q, right, as the lowest node in T, right, in the tree, right, that has both P and Q as descendants. I'm saying, and it says where we allow a node to be a descendant of itself, right? This is a very, very important aspect that they're telling us, right? So a node can be a descendant of itself, guys. So yeah, they bolded for a reason, all right? Cool. So now let's look at a couple examples, all right? So this is the tree, right? And then we're looking for the lowest common ancestor of 2 and 8, right? So lowest common ancestor, guys, just to clarify, is the last common node, right? That the nodes have in common, right? I'm saying. So for this example, right, we're looking for 2 and 8, right? The last common ancestor, right? So 2 is on this side, 8 is on this side, right? The last common ancestor that they have in common, guys, is 6. So I'm saying, which is the root, what I'm saying, so we return 6, what I'm saying, because that's the last common one, what I'm saying. And in this one, that's a very interesting case that they have, right? Which is the tree area. But now we're looking for nodes 2 and 4, the last common ancestor of 2 and 4, what I'm saying. So now we search, right? So we go to the left side, right? So it's 2 and 4 on the left side, and then we here, right? We're at 2, and then we see that 2 and 4, right? And then 2 is a 2, we return 2 because 2 is the lowest common ancestor, I'm saying, because it said that a node can be a descendant of itself, what I'm saying. So that's what we end up returning 2. I'm saying, let's say 4 was on top, right? 2 couldn't be in the bottom because, you know, it's a binary search tree, but yeah, it's a little bit different. So as you guys can see, we saw 2, right? We returned 2 as the lowest common ancestor because, you know, of 2 and 4, I'm saying. Yeah. So yeah, likewise, if we had 8 and 9, right, and then we're looking for 8 and 9, right, and then we saw that we found 8, right, so 8 would have been the lowest common ancestor, I'm saying, so we return 8, I'm saying, because it said that a node can be a descendant of itself, right, which is a very important thing. So the way we're going to go about solving this, guys, I'm saying it's a very, very easy way of doing this. Since this is a binary search tree, we can use the properties of a binary search tree, I'm saying. There's another problem that's called lowest common ancestor of a binary tree, right? Which is a little bit more complex, but it's still pretty simple, but it's more complex. But this one, since it's a BST, right, it makes it, you know, very easy to implement for solve, right? So the way we're gonna go about it, guys, I'm saying. So we're gonna keep. So let's say we got 2 and 8, right? We keep searching for it, right? So we see does 2 and 8 exist on the left side? We go left, right? Does 2 and 8 exist on the right side? We go right. At the node where the two nodes, right, end up splitting, going in different direction, right? They cannot both go to the left side, or they cannot both go to the right side. We return that node, right? I'm saying, so that's how we're gonna go about solving the game, I'm saying. So it's gonna be very good. So look at the example, right? We see 2 and 8, right? 2 is on the left side, but 8 is not on the left side of 6, right? Because 8 is greater, so we branch out, I'm saying. So we just will return 6 as the node, right? Likewise, for this example, right, we see 2 and 4, right? 2 and 4 can be on the left side of 6 because they're both smaller than 6, right? So we go to the left side, right? And then we're at 2, right? 2, we see 2, right? And then we see 2. Can 2 and 4 be on the left side? Nope. Can 2 and 4 be on the right side? No. Only 4 can be on the right side because 2 is not bigger than 2, I'm saying. So it can't go on the right side, I'm saying. So we return 2 as the lowest common ancestor, I'm saying. That's the whole algorithm, guys. So let's just do it really quickly, okay? So now, guys, we're gonna use a helper function, right? It's gonna have literally the same method signature as the as this function that we're currently on right now. So I'm just using a helper function, guys, just to keep it consistent in all of the different problems that we've done, right? I've always used a helper function, so that's why I'm keeping it consistent. So I'm literally copying the signature, you know what I'm saying? So we just helper, okay? All right, so we do the check, guys. If root is null, we return, right? We return null, right? As edge case, right? Now the next thing that we're gonna do, guys, you know what I'm saying? So we're gonna see if we can both go to the left side, right? Okay, to binary search tree, I'm saying that's where you do that, what I'm saying. So we check, right? Does root, the current root that we're currently on, root.val, right? Is it greater than p.val, right? At the same time, is it greater than q.val as well, right? If it is, guys, what I'm saying, we both go to what's it called? If it's greater, right? If the root that we're currently on is greater than p.val and q.val, they both go to the left side, you know what I'm saying. And also if we also pass in the p, we pass in q, right? And then else, guys, you know what I'm saying, if root.val is not greater, right, then it has to go to the right, you know what I'm saying. Going to the right side, you know what I'm saying. So passing p, passing q. All right, at the node that we cannot, they cannot both go to the same spot, either left or right, right? We return, yeah, my bad. I think this needs to be an else if, actually. Can they both go to, if root.val is less than p.val, right? And root.val is also less than q.val, I'm saying. They both need to be valid, you know what I'm saying? So, yeah. So, like I said, you know what I'm saying? So, if they cannot both go to the left side or they cannot both to the right side, then they end up branching out. The root that you're currently on is the node that's it's the lowest common ancestor, I'm saying. Just see if we pass the small test case. Perfect. Let's see if we pass all the test cases, guys. I'm saying. Perfect, guys. We're able to pass all the test cases, guys. Now, I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this video, and I'll see you guys in the next one.